Welcome, Math 252. We're looking at problems 44 through 47 of from section 5.4 of the Hughes-Hallett text. So we're given a graph, a generic graph of a function f of x in an interval a to b, and we're asked to find in these problems a bunch of different lengths. So let's start with problem 44, where we're asked to find f of b minus f of a. We're supposed to indicate a length in the graph that represents that number. Well, here I've drawn a and b, and the heights f of b and f of a, and the vertical red line you see there is the difference between f of b and f of a. It's the distance between f of b and f of a. So there's problem 44. 45, we're supposed to find a slope that represents this difference quotient, where we have f of b minus f of a over b minus a. And here I've drawn the line, the red line that has that slope. If you look at that line and go to calculate its slope, the change in y between the two endpoints is f of b minus a, f of a, and the change in x is b minus a. The slope of that line is represented exactly by the formula in the problem. So that's what we're looking for in 45. In 46, we're supposed to find an area that represents capital F of b minus capital F of a, where capital F prime is little f. That is to say, capital F is an antiderivative for little f. The area is just the integral of little f from a to b. It's the region I've indicated in black. Why is that the right thing to do? Well, if capital F is an antiderivative for little f, in other words, if capital F prime is equal to little f, then the fundamental theorem of calculus, the basic fact that you need to know about definite integrals, is that capital F of b minus capital F of a is the integral from a to b of little f with respect to x. In other words, the change in capital F can be gotten by integrating its derivative, little f, and that's exactly what we've done here. So there's problem 46, and finally for problem 47, we're supposed to find a length that roughly approximates this second difference quotient, capital F of b minus capital F of a over b minus a. Now we've just established that capital F of b minus capital F of a is the integral of little f from a to b. So I can replace the top of this fraction by the integral, as you can see here in this bit of math I've written here, and just leave the 1 over b minus a alone, and you should recognize that as the formula for the average value of little f on the interval a, b. So in this drawing, I've roughly indicated about where that height would be. The average value of little f on that interval is going to be a number between f of a and f of b, and the vertical red line roughly represents that height.